ladies and gentlemen.
This is the Milks and MoNaCo show.
Yepper. We are in our fourth homework lecture in our pack.
Yep, page number 8.
And this is where, at this point, after this, you got to do some practice.
Yeah, seriously.
Right, because there was no practice with the vocab and the background information and the
How do
Arrhenius
we
theory,
recognize acids and bases?
at a glance.
Yeah, like from their name.
Well, it's easy.
It is. So, characteristic of acids. They will usually start with an H.
So a hydrogen atom at the beginning of their formula.
There you go. They will have a pH lower than 7. They are caustic, which means will burn you, and they are generally sour to taste.
Yes, and acids are in a lot of our foods. Weak acids are in a lot of our foods.
Yeah, salad dressing vinegar, right?
Yep.
Acetic acid.
Citric acid.
Yep. All our juices.
Yep. And the names you'll see next page of notes has something to do with what they are too.
Ooh, there's another good one. It'll eat your teeth.
Hydrochloric acid.
Ooh, carbonic acids in your cola.
Phosphoric acid in the cola too. Literally, Coca-Cola has ingredients phosphoric acid at the end. It's got that tang.
Carbonic acid that I was always under the impression was the carbonic acid.
Either one, don't matter. It's gonna acid's gonna react with the bone in your teeth.
Yeah, you put one of your baby teeth in there that mom's been saving. You drop it in a can of Coke, and it's gone within a week.
It'll melt, yeah, because the acid reacts with the elements in your teeth and bone. But moving on, bases usually end with an OH or hydroxide group. pH is always going to be higher than 7. They are also caustic, but in an opposite kind of way. They don't cause acid burns, they cause base burns, which are really slow and kind of weird and don't hurt until later, in my personal opinion. It makes them slippery because that base reacts with the fats and oils in your skin
to make soap.
So if you've ever used any like artisan soap from like the farmer's market, or you've tried to make soap at home, sometimes it can really dry your skin out and makes it you have like dry skin and rough patches. It's because it's caustic.
Yeah.
And it will.
They're basically going to take fat and hit it with lye
and turn it into soap. So if it's not pH balanced after that, it could cause damage to your skin. But guess what? All that Lever 2000, any soap you buy from the store, has been pH balanced after, so that it doesn't cause those problems.
Correct.
Or it shouldn't.
And it'll also be bitter to the taste.
Right. We don't eat bases too often.
No.
Except dark chocolate, pure cocoa.
Ooh,
it's called the Dutch process cocoa because they use base to make it stable in shipping and packaging and make the powder.
There you go.
So it's basic bitter because that's dark chocolate. That's how they make it. They use a base to get it to be stable.
Nice. All right, that word salts. Now, we're not talking about just table salt here. We're talking about any ionic solid is considered a generic salt.
Yep.
It's always going to be a metal and a non-metal. Will dissociate in water. And it is the product of a neutralization reaction, which is part of this unit.
So an acid and base get together, they make salt and water. We'll see that later, but we had to give a little properties for salts too.
Yep. There you go. So, nomenclature. You doing acid or are you doing base?
I'll do acid.
All right, you do acid.
Whoa, man. Haha, just kidding. So a spectator ion is the root of the name, and then they all end with ic or oic acid. So for example, in table K, you should never have to guess to see if something's an acid or not. Go look it up. It says common acids. Those are the ones that are testable. So you'll notice every single one of them end with acid as a second word. And then you go to the first word, you see the root there is based upon the molecule or the negative ion, okay? The spectator ion is what we call it. And they always end in ic. So that's it.
Just about. There's the us's, but we won't get into that.
Yeah, we're not going to us or ics. But so, moving on.
They're almost always ic.
HCl for the formula becomes.
That's why I spelled become drunk.
Oh, hydro for hydrogen. Chlorine, Cl. Ic acid. So we got to put those three together, and you get hydrochloric acid. So the hydrochloric is the root there. Acid. Well, chlor is really the root.
It's really it's the only one with hydro, so we wanted to use that as an example.
Right. So the rest of them, as you can see there, nitrous, nitric, sulfurous, sulfuric, phosphoric, has to do with the NO2, the NO3, the SO3, the SO4. That's how we get the names. It's the spectator ion that gives us the root.
Generally with an ic acid at the end.
Usually.
Bases are even easier.
Drop that base.
That's right. We're going to name the metal, and then we're going to end it with hydroxide.
Simple.
It's as simple as that. So I got NaOH will become now sodium hydroxide, merge them together, Done.
End of story. And the only one you really got to know about here is that NH3 is not following that pattern for a different reason. It's part of the alternate acid-base theory, Bronsted-Lowry theory we showed you in the previous videos. So we don't put a hydroxide in there because it doesn't have the hydroxide group.
Correct.
Arrhenius originally didn't know about ammonia acting this way. Ammonia is a relatively modern chemical in the last 200-300 years, and I think Arrhenius was before that. So,
okay, fair enough.
anyways.
And just for our naming structure, the COOs are the organic acids that don't start with an H.
Ethanoic acid.
Yeah, notice it doesn't start with an
CH3,
H necessarily.
COOH, yeah.
So there's a discrepancy.
But the second way we write it, the HC2H3O2
yeah, but you
does.
know the big bad test never writes it.
They're
that
the
way.
same. You're right.
But I'm just saying there is kind of a discrepancy in each one. So that's it. Know how to recognize your acids and bases. Do your practice. Make sure you can do it. If you got a problem, come see us.
In my mind, there's really only two ways. One, you've memorized the nomenclature, or two, you go and look at the reference tables.
Yeah, seriously, they do a good job of not asking us other acids and bases if they're not on the table. So
Never.
that's it.
Thanks.
But I didn't